Okay, number 3 here. A says in a standard deck of 52 cards, what's the probability of drawing 5 cards without replacement and correctly guessing them? So at first, there's 5 cards that I've guessed. And that's out of 52. What ends up happening if I've picked one card correctly out of 5, or I've guessed 1 out of 5, now there's 4. If I pick another one, there's 3. Pick another one, there's 2. Pick another one, there's 1. Meanwhile, the total cards do the same thing. They go down. Ultimately, a faster way of getting to this answer would be taking permutations. And you can check that 5 times 4 times 3 times 2 times 1 is ultimately 120. If I do a permutation of I have 5 things and I'm picking 5 of them, there's 120 permutations there. In the denominator, to speed things up, I'd use the permutation function on my calculator. So I got 52, and I'm picking 5. So I could just divide that. I could multiply all this out. That's cool too. And they both come out. The probability of doing this is really, really high. And that's why card tricks are impressive. It's ultimately 311,875,200. We divide that out, and it is a tiny, tiny number. You'll get an E on your calculator. Well, if you have, make sure you divide, not multiply, which I just did. You get 3.848 e to the negative 8. That means you have 8 decimals leading up to that 3. Okay. As a percent, that's not a great percent either. It's astronomically low that actually happens that way. Okay. Even just picking one card out of 52 correctly, like that is only a 2% chance. So each time and it comes out to 1.9 or 0.0192 is the decimal value, 1.92% if you round to the nearest 100. Okay. B. So now we're choosing, can we get all hearts? So on test day, I'll give you a deck of cards or a diagram of them. Ultimately, there's 13 hearts in a deck. So B is a lot like A. The probability will be higher because the numerator is much, much higher. So we've got 13 now, and we're picking 5. And again, I can actually take and put these two things in my calculator. I can go 13, and I'm picking 5. So 13 permutations of 5. And divide that by and take and divide that by 52 permutations, 52 cards, and I'm picking 5. Or I can write it out. Your choice. Either way, both answers come out the same. And now we've got 4 decimal places before the 4. So as a percent, that would be 495 ten-thousandths of a percent chance. Okay, not even a 0.1%, not even 1/10 of a percent of a chance. We would have, that would round to 5/100ths of a percent of a chance. Okay, and lastly, C there. Now, we have, the key word here is replacement. So each time, there's 13 chances of getting a heart, and that happens 5 times. There's 52 cards, but every time I put them back in. So I'm drawing, each time the probability is 13 out of 52. So I need to do 13 to the 5th and I need to divide that by 52 to the 5th power. And this is actually the highest probability on here. It's still really, really low, 0.0097, we'll round up 77, which is the same as 977 10,000ths, or really close to yeah, decimal moves 2 times. Really quite close to 1/10%. Ultimately 0.098%. Okay. And closing it, not 1/10, closing in on 1/100%. Still very, very low. And that concludes probabilities with decks of cards.